going over that worksheet, right? 15 or 52A, and let's I don't know. Do you want to? Should we go through every one, or should we just pick and choose a few? Everyone? Okay, that's kind of what I thought. All right, let's do that then. We start off with white all the time. Let's start with a different color for once. All right, number 8, 4 to the x equals 2. Now, some of these, I really didn't show you any really good approaches, okay, good techniques. That's a better word to use. That's what I was trying to think of. We need to think of different techniques, not a trick, but different techniques to solve these things. This is the first technique that we talked about. Actually, the only one that we talked about is to try to get the bases the same. Do you remember that? If I have a to the x equals a to the y, if the bases are the same and you have exponents, what can I do with those exponents? I can set them equal to each other, right? Because if this was a to the second, what would this have to be in order for them to be equal to each other? It would have to be a to the second, right? So x would equal y in this case. Does that make sense? All right, so what we want to do is try to get these so they get the same base. Well, this base is 4, this base is 2. Which one am I going to change? Well, normally we would take the larger one and change it into the one that's the smaller one. All right, so is there a certain base that I could change both of these into? Well, 2, right. I could change 4 into what? 2 squared. Isn't that the same thing as 4? And it has a base of 2, so I'm good to go with that. But this 4, this 2 squared, is being taken to the x power. So I'll put the x right there. Isn't that the same exact thing? Isn't that 4 to the x? Yes, it is. 2 to the 2x is the same as 4 to the x. And that's equal to 2. Now, since I have exponents here, and I've talked about exponents, let's write this with an exponent. What would the exponent be? You don't normally see it, but it's there all the time. It's always a 1, isn't it? So I'll put a 1 there just so that we know. Now we got this situation. Now we have bases are the same, and what do we do with the exponents? Set them equal to each other. That's right. So I set 2x equal to 1, and now I just do regular algebra and just solve for x. So I divide both sides by 2, and x is a half, and that's your answer. Pretty easy, isn't it? Again, once you realize the technique. That was number what? 8? Yep. All right. Questions on that? Anybody have a question on that one? Does it seem pretty easy to you? Yeah, that one's pretty easy. Now, sometimes finding the base is not exactly that easy. This was about as easy as you could possibly get, to tell you the truth. Okay, if you have 4, you know 4 is 2 squared, so that should be good. Jared, you still with us? It's pretty early. You start nodding off already, isn't it? All right. You gotta live up to your to the prize that you won at prom, though, right? You don't want to let anybody down, I guess. All right. So it's 1/3 to the x is equal to 27. All right. This is the same idea, but the technique is a little bit different. It's a little bit trickier to find what would be the same base. Now remember, we want to take that larger one and try to make it the same base as the smaller one. But this one's a little different because I'm actually going to change both of them. I'm going to change both of them so I get the same base. Now, they didn't just put a random number here, okay? They purposely put a 27 here and put a third right there, or that 3. They did that on purpose so that you could get the same base, all right? They're not just going to put some random stuff in there where you can't get the same base. Not right now, anyway. So what do you think we're going to do? Let's take a look at this one. How do you think we're going to rewrite this? 27 should be one of those numbers that kind of jumps out at you a little bit. How can I write something to a power? What to a power is 27? 3 to the third. Good. 3 to the third. So let's do that. That's about the only thing I can think of as far as 27 is concerned. It's not 2 to anything. It's not 9 to anything. 3 to the third is about the only thing I can think of if you take a base to a power. Problem is, that base right there is not a 3, is it? It's a 1/3. So I'm going to have to do something with that. How in the world could I change 1/3 so that it's a 3? Okay, that's right. Watch this. If I took the 1/3 and if I took the inverse of this, right, it would be a 3. Would you agree? How do I take the inverse of something? I take it to the what? To the negative first. Okay? Follow me? So what I'm going to do is this. I'm going to flip let's do this. Let's not say to the negative first right now. What I'm going to do is I'm going to flip this thing. But if I flip this fraction, what am I going to have to do to the exponent? I'm going to have to change the sign of the exponent. So that's what Destiny said, 3 to the negative x. Now, did we write it with a base of 3? Yeah. Do you understand why I used the word trick before? It's kind of like a little trick, isn't it? All right. It's a technique. I like that word better. I'm glad I thought of that today. But that's what we do. We had to manipulate these numbers just a little bit. We had to change the numbers around to fit our rule, to fit what we want to do. So I made that to a base of 3, and I took that, made that to a base of 3. But if I take this and flip it, I got to change the sign of the exponent. I mean, that's really nothing new. We've talked about that rule before, that we could do that. You just may not have thought about doing that in this situation. Now, let's see what we get. Now we have the same bases, don't we? So what do we do with the exponents if I have the same bases? Set them equal to each other. So negative x equals 3, and x equals what? Negative 3. And how do you know that? Well, you could divide both sides by negative 1, or you can multiply both sides by a negative 1, or however you want to look at that. So that was a little more challenging than the first one. Would you agree? All right? But hopefully you understand what we did there. Now, you may see some problems like this later on, so remember that technique. It takes a little creativity, to tell you the truth. And a lot of people scoff at that, and they say, creativity in math? Are you kidding me? You don't have to be creative at all to do math. But I think a lot of times you do. You really have to, you got to think outside what you normally do, and still stay within a set of rules. But I definitely think it takes a little creativity on your part to think of some of this stuff. All right. Flip page, number 10. Oh, look at this crazy thing. 4 over 3 to the x equals 81 over 256. Now again, it might look like these are just random numbers they just picked out of the blue, but they're really not. Okay, they rig these things, all right, for what we're doing in high school anyway. They're rigging these things so we can manipulate them, get the same bases and all that kind of stuff. Let's forget about this 4/3 to the x right now. Let's just take a look at this one. This one's the one that looks a little more complicated. I got 81 over 256. This is where a calculator could be helpful. Okay, if you don't know some of these numbers off the top of your head, then it might be good to plug it into a calculator. What we need to do is like that other one, like 27. What did I ask you to do? Think of a number to a certain power that's 27. Well, let's do the same thing with 81. Can you think of something to a power? Okay. 3 to the 4th. Is there anything else? 9 squared. The first one I would have thought of would be 9 squared. I mean, Tiffany's right. 3 to 4th is what we're going to use here. But if I was looking at this number 81, I would have thought 9 squared. But is there any way to write 9 to a certain power that's going to give you 256? Because I need the same base here, don't I? I want the same base to a certain power. Actually, I'm sorry, I lied. You don't need the... Shh, Tiffany, please. You don't necessarily need the same base. You need the same exponent, okay? Actually, no. It could be either way. All right, that's why I said both, I guess. It could be either way. You could either get these to have the same base or these to have the same exponent. All right. So what do you think? Is there any way to get like something squared that's going to give you 256? I don't know. Let's try some. Well, like 10 squared is 100, right? 11 squared, 12 squared is 144, 13 squared. What's 13 squared? That's 169, isn't it? 15 is 225. Let's try 16. Let's try 16 squared. I don't know what that is. Let's see what that is. Oh, it's 256, isn't it? So look at this. So 9 squared is 81, and 16 squared is 256. Would you agree? So we could write this like this. 9 over 16 to the what? To the second power. Wouldn't that be true? Now look at the 9 and the 16, and look at this 4 and this 3. Tell you what, let's do this a little bit more. And remember I said what Tiffany said right off the bat, that was the way to go. But if I went this way, you could still get this to work, but Yeah, let's just continue with this. What could I do here? I could say this is 3 squared, couldn't I? And I could say this is 4 squared, but that's all to the what? To the second power. So really this is what? This is 3 to the 4th over what? 4 to the 4th. And if you would have maybe thought of some things that are 81 to begin with, that might have been a little bit easier. I don't know, there's all kinds of ways you could look at this. Because look, 3 to the 4th, would you agree 3 to the 4th is 81? 3, there it is, to the 4th, it's 81. And let's see what 4 to the 4th is. 4 to the 4th, that's 256. So would you agree that that is true? But that takes a little bit of thought. It takes a little imagination, a little ingenuity to come up with that. So how could I write this then? I could write it 3 over 4 to the, what, 4th power. And you could get to that a couple ways. I probably didn't get to it the best way, but I got to it the way that I was thinking. You know what I mean? Like when you're driving down the road and you know you want to get somewhere, you may not know the best exact route to get there. Let's pretend we don't have GPS. But you know you can get there. You know what I'm saying? You might have not gone the most direct way, but you know you can get there. So go with what's familiar to you. If that road's familiar to you, then go down that road. And that's what I just did right there. Probably not the most efficient way to do this, but it's the way that I thought of. Okay, when I saw 81, I thought 9 squared. Okay, I think most of you thought that. And then I said 256. I wonder if I can get something squared that's 256. Punched in a couple things in the calculator. Sure enough, 16. All right, so I got this squared. And I looked at this. I'm like, wait a minute. There's something else that's squared that's 9 and something else squared that's 16. And that's 3 and 4. So I went that route. And then I got 3 to the 4th, 4 to the 4th. And that's where I ended up with that. But I still got a problem. What's the problem? They're still not the same bases, are they? All right. But what can I do? They're really, really close to the same base. This is 4 over 3. This is 3 over 4. They're just inverses of each other, right? So what do you think? Let's take this to the inverse, right? You could do to either one. It really doesn't make any difference. Which one do you want to do? The first one or the second one? First one? Okay. Let's take the inverse of this. So if I take the inverse of that, that would be 3 to the 4th. But I can't just take the inverse of that. What else do I have to do? I got to change the sign of the exponent. So that's going to be to the negative x. And this I'm not going to change. Why am I not going to change it? Because now they're the same base, aren't they? Now they're exactly the same base. So if they're the same base, what can I do with the exponents? Set them equal to each other. And then x is negative 4. Thank you. So that took a little bit of thought, especially for this part right here. Once you got down to this was kind of the same as what we did on the other problem. But this definitely took a little bit of thought. So practice it. All right. Of course, they could give you different numbers here next time, but that's a good way to do this. All right, let's stop this video and go to the next one.